Basic electronics. The idea of this video is for the viewer to know basic electronics. What is, when we talk about electronics, at least the groundwork can be established. So the objectives will be defining the basic components of the electricity, then recognizing the three electrical classifications of materials, and comparing and finding the difference of AC and DC. AC is alternating current and DC is direct current, and then explaining the concept of grounding, then using Ohm's law and Watt's law to express the relationship between current, voltage and resistance. So electricity can be broken down into first electric charge, then voltage, then current, resistance. So there are two type of charges. One is negative, one is positive. So what do the effects of electricity in TV, radio or battery and lightning all have in common? Basic particles of electric charge with opposite polarities, electrons. When we talk about electronics, it comes down to electrons. This is the smallest amount of electric charge having the quality called negative polarity. Okay, electrons are negatively charged. Electrons, they orbit the center of the atoms. Then comes the protons, and the proton is a basic particle with positive polarity, that is, proton is positively charged, and the protons are located in the nucleus of the atom along with the neutrons. Neutrons are, as the name suggests, they are neutral, and these are particles which have neutral polarity. So this is how protons and neutrons are established in an atom. See, if we talk about hydrogen, it has one proton and mass is 1. Again, here the protons and neutrons in helium, they are 2 plus 2 is 4. So this is how they are in an atom. Diagrammatically we can show them. This is the nucleus. It has proton inside, neutron inside, and these are the electrons which are moving. So these two are Z. This one is Z. Now electrically all materials fall into one of three classifications. So there are three basic classifications. One may be conductors, insulators and semiconductors. What are conductors? They have one valence electrons, that means one free electron. And materials in which electrons can move freely from atom to atom are called conductors, because they can contain or they can move with the electric charge. So in general, all metals are good conductors. So the purpose of conductors is to allow electrical current to flow with minimum resistance. Resistance is, as the name suggests, resist. It tries to stop the current. Then comes the insulators. They have 8 valence electrons, no free electrons. Materials in which electrons tend to stay put and do not flow easily from atom to atom are termed as insulators, because there is no electron, there is no free electron to move around and carry the charge. And the insulators are used to prevent the flow of electricity. It prevents. So can somebody say that it has infinite resistance? Let's see. Now the insulating materials such as glass, rubber or plastic are called dielectrics, meaning they can store charges. Means they can have charges which can embed into them. They can store the charges, and dielectric materials are used in components like capacitors, which must store electrical charges. Now the third classification is semiconductors. They have 4 valence electrons. See, one has 1 electron, the other has 8 valence electrons. Semiconductor has 4 valence electrons. Materials which are neither conductors nor insulators. Common semiconductor materials are carbon, germanium and silicon. These are used in components like transistors. So the symbol for charge is Q, which stands for quantity, and the practical unit of charge is coulomb, C, capital C. So 1 coulomb is equal to the amount of charge of 6.25 in 10 to the power 18 electrons or protons stored in a dielectric, because electrons and protons are always same. Now we are talking about voltage. This is the potential, which refers to the possibility of doing work. Any charge has the potential to do the work of attracting a similar charge or repulsing an opposite charge. The symbol for potential difference is capital E. This is for electromotive force. And the practical unit of potential difference is volt. This is capital V. And 1 volt is a measure of amount of work required to move 1 coulomb of charge. Then comes the current. When a charge is forced to move because of a potential difference, that is the voltage, potential difference current is produced. So in conductors, free electrons can be forced to move with relative ease since they require little work to be moved. So current is charge which is in motion. The more electrons in motion, the greater the current. Then comes amperes. The current indicates the intensity of the electricity in motion, and the symbol for current is capital I. This is for intensity T and is measured in amperes. So the definition of current is I, which is equal to Q by T, where this I is current in ampere, this Q is charge in coulombs, and T is time in second. So 1 ampere is 1 coulomb per second. This, if I explain this diagram, this is an imaginary plane. This is a piece of copper wire. So when the amount of charge that passes point in 1 second is 1 coulomb. The current is termed or called as 1 ampere. This is how electron is flowing. Now resistance, I earlier mentioned, the position to the flow of current is termed as resistance. The fact that a wire can become hot from the flow of current is evidence of resistance. And conductors, they have very little resistance. And insulators, they have large amounts of resistance. As I was explaining in earlier slide, may it be infinite. Now coming to ohms, the practical unit of resistance is the ohm, designated by the Greek letter omega. This is ohm. A resistor is an electronic component designed specifically to provide resistance. And closed circuit, in application requiring the use of current, electrical components are arranged in the form of a circuit, and a circuit is defined as a path of current flow. So common electric component symbols are: this is for battery, this is for a resistor, this is for a switch, this is for a diode, and this is for a LED, light emitting device. Then a complex audio circuit can be like this. It has all components which we have just talked about, and more of them also. This, these are different electrical or electronics parts, but the basic idea is all coulomb, volt, resistance, all work in tandem. And what we talk about open circuits, this is A and B, there is no connection, this is open. So a current can only exist when there is a conductive path. This cannot conduct an electricity in the circuit shown here. Since there is no conductor between points A and B, this is an open circuit. The circuit is a load on the voltage source. The circuit is where the energy of the source, that is the battery, is carried by means of current through the various components which are in the circuit. So the battery is the source, and it provides the potential energies to be used, and the circuit components are the load resistance. They determine how much current source will produce. And the direction of electron flow, in the circuit from the negative side to the battery through the load resistance back to the positive side of the battery. So inside the battery, electron move to the negative terminal due to the chemical action, maintaining the potential across the leads. So this is electron flow in the simple circuit. And when we talk about DC, that is direct current, circuits that are powered by battery sources are termed as direct current circuits, DC. This is because the battery maintains the same polarity of output voltage, thus plus and minus sides remain always constant, like this. So this is a steady voltage, and this is the waveform of DC voltage, always steady. Voltage time, always steady. This is a always steady voltage, VDC. And what are the characteristics of DC? It is the flow of charges in just one direction, and the fixed polarity of the applied voltage, which are characteristics of DC circuit. And the counterpart of DC is AC, that is alternating current, which is an alternating voltage source, periodically alternates or reverses in polarity, and the resulting current therefore periodically reverses direction. So the power outlet in your home is 60 cycle AC, meaning the voltage polarity and current direction go through 60 cycles of reversal per second. Every second 60 cycles of reversal. So all audio signals are AC as well. This is the waveform of AC voltage. You can see this is how it is changing, and there is no constant VDC. There is a, you can see the amplitude. There is a range of amplitude where it varies to plus minus. This is a sine wave voltage. And this complex voltage signal is like this, and this is more realistic view of what the audio signal voltage would look like. So if we compare AC and DC, DC has fixed polarity, AC reverses polarity. DC can be steady or vary in magnitude, AC varies in magnitude between reverses in the polarity. And DC voltage, it is steady value, cannot be stepped up or stepped down by a transformer, whereas the AC is used for electrical power distribution. And DC voltage, the electrode voltage for tube and transistor amps, while the AC voltage, the input output signal for tube and transistor amps. And DC voltage is easier to measure, and AC voltage can be, because it has amplitude also, it can be easily amplified. But the heating effects are the same for both AC and DC current. So many circuits, they include both AC and DC voltages. The DC circuits are usually simpler than AC circuits. However, the principle of DC circuits also apply to the AC circuits. Now coming to impedance, impedance is a resistance to current flow in AC circuits, and its symbol is Z. So impedance for AC, resistance for DC. Impedance is also measured in ohms. Now what is grounding? It is the wiring of practical circuits on one side of the voltage source, which is usually grounded for safety. So grounding is for safety. For 120 volt AC power lines in homes, this means one side of the voltage source is connected to a metal cold water pipe, and for electronic equipment, the ground just indicates a metal chassis, which is used as a common return for connection to the source. So common symbols and names for ground in electrical circuit: this is earth, this is ground, this is chassis. Now Ohm's law. What is the Ohm's law? The amount of current in a circuit is dependent on its resistance, and the applied voltage specifically is what I is equal to E by R. And we know I and R. If you know any of the two factors, you can always calculate or compute the third. This is current. I is equal to E by R. Voltage E is equal to I by R. Resistance R is equal to E by E. So current is directly proportional to the voltage for a constant resistance. This is the Ohm's law. You see, if you plot a diagram between voltage, that is V, and I, this will always remain, E will always follow a constant or proportional value. So current is inversely proportional to resistance for a constant value. You know, the Ohm's law is just a statement, but it applies to E, I, and R, and this is how current and resistance variate the voltage. This is inversely proportional. Then power, the unit of electric power is the watt. The power is how much work is done over time, and 1 watt of power is equal to the work done in 1 second by 1 volt moving 1 coulomb of charge. Since 1 coulomb a second is an ampere, power in watt will be volt into ampere. You know, I need to re-emphasize that power is volt into ampere. P is equal to E into I, and there are 3 power formulas. P is equal to E into I, P is equal to I square R, P is equal to E square R. You put your Ohm's law here and you will get all these 3. These are the conversion factors that if we have mega, we put the symbol capital M. The relation to basic unit is 10 to the power 6, kilo 10 to the power 3, and milli 10 to the power minus 3, and micro 10 to the power minus 6, M, K, M, mu. Thank you so much. Take care of yourself.